The traditional heavy-duty engine is defined by vibration and exhaust. A modern electric motor presents a different reality. It is silent, clean, and increasingly dominant. This growth is most visible in China, where the market penetration for new energy heavy trucks surpassed 30% in late 2025. For decades, the industry has stalled because of the weight penalty. The assumption is simple. A 2-ton electric battery forces a truck to carry less cargo, effectively killing the profit margins that long-haul trucking depends on. Western markets have largely hesitated because of this assumption, concluding that the physics of heavy batteries make electric freight financially impossible. But logistical data paints a different picture. In freight, a truck weighs out when it hits its legal weight limit, and it cubes out when the trailer is physically full. Because modern e-commerce cargo is voluminous but light, trailers almost always run out of space before they ever reach their maximum weight. Look at the actual utilization rates in the U.S. market. On average, 58% of truckloads move underutilized, leaving about 34 linear feet of deck space completely empty. This means the majority of trucks on the road have more than enough spare weight capacity to absorb a heavy battery without sacrificing a single box of cargo. Even in weight-sensitive sectors like construction, new regulations are removing the obstacle. The European Union's Directive 96/53/EC now grants zero-emission vehicles an extra 2-ton weight allowance, specifically to offset the mass of the drivetrain. The weight penalty exists in the lab, but for real-world freight, the empty space inside the trailer makes the added mass irrelevant for most operators. The financial shift starts with daily operating costs. Diesel costs 50 to 70 cents per mile, while electrics run for 15 to 25 cents. This efficiency gap widens by environment. On highways, electric trucks are 3.5 times more efficient, surging to 7 times in city traffic. China scaled this advantage through its Two New policy, committing 300 billion yuan in special treasury bonds to accelerate fleet renewal. This funding fueled a massive scrappage scheme, dismantling millions of high-emission diesel trucks while establishing a formal national recycling ecosystem for the resulting scrap steel and old batteries. By treating fleet renewal as a matter of state industrial policy, China used public funds to clear the high upfront cost of electric trucks, allowing operators to immediately access the lower per-mile rates. To solve the problem of charging times, the Chinese market moved toward battery swapping. Instead of plugging into a charger for hours, a robotic arm extracts the depleted battery module and replaces it with a fully charged unit in about 5 minutes. Systems like CATL's Qiji energy utilize an under-chassis layout. Placing the battery just 180 millimeters off the ground lowers the center of gravity and significantly improves the truck's stability during high-speed maneuvers. This infrastructure works across different brands because of the GBT national standards. These regulations mandate universal battery connectors, legally enforcing interoperability. This allows a truck from any manufacturer to pull into any swap station, regardless of who built it, and receive a new battery. While Western manufacturers focused on building isolated, proprietary charging networks, China legislated a unified, open-access logistical ecosystem. This has brought the industry to total cost of ownership parity. In the Chinese regional market, electric trucks became cheaper to own and operate than diesel models in 2024. The primary driver is the shifting chemistry of the batteries. Lithium iron phosphate, or LFP, has become significantly cheaper to produce and can withstand thousands of charge cycles, making it the ideal chemistry for heavy-duty work. Operating costs are further reduced by regenerative braking. By repurposing kinetic energy to charge the battery, these systems extend the vehicle's range and virtually eliminate the need for routine brake pad replacements. Some operators are now using battery-as-a-service models, where they buy the truck but lease the battery. This removes the single largest expense from the vehicle's initial sticker price. Between lower energy costs, reduced maintenance, and subsidized purchasing, the financial case for the diesel internal combustion engine in China has largely disappeared. Western markets are now in a race to the grid, struggling to build out the high-voltage connections required to support 5-megawatt charging stations for their emerging fleets. China, meanwhile, is already operating 1,250-kilometer electric freight corridors along major expressways, supported by standardized high-speed swap stations. Their current target is 180,000-kilometer national network by 2030, covering the vast majority of the country's primary transportation routes. We are seeing the result: a supply chain that is cleaner, quieter, and fundamentally cheaper to operate than the diesel system that preceded it. By standardizing infrastructure and restructuring economics, China has moved the global logistics industry into a new phase where diesel is no longer the competitive choice.